I know there's a great turnout and want to get throw the audience some questions. Well, I'll take the first one for myself and then move to the audience. There was, I mean, through all the presentations, there's a lot of good stuff out there. I think we've focused a lot on some of the hardware out there, the things that are being done at Intel, the things that are being done, or the needs we have for physical infrastructure. But there's also a knowledge component to this, and I'd be curious for Steve and Tim. And your companies are, known as manufacturers of chips and manufacturers of chemicals, but you've also described the expertise that's developed within your companies as water. I wonder if is there an exporting or a selling or a monetization of that expertise your companies have in that water, and then maybe from on, is there, with your sort of experience coordinating among that, is there, like, how is this that knowledge of advanced treatments sort of getting out? So I'll throw it to whoever wants it.
Yeah, I'll take a first crack at it. Within Dow, certainly that's true. So we have a group called Dow Water Solutions, sells UFRO membranes. We have various companies that have come together that sell ion exchange membranes. And I like to tell folks, I think we've had almost every water problem I can imagine inside the company. And so we do a pretty strong collaboration of folks that are on the manufacturing side with folks that are on the sales side of kind of our water market-facing side of water management. And it really does create a hub to innovate and, for the folks that are on the sales side, kind of get an in-house look at what the needs are.
Yeah, there are really a couple of different answers within Intel. We don't have a business unit that focuses on the water sector and sales of our hardware and software. And by the way, we make a lot of software. We have tens of thousands of software engineers. But we do have a vertical on the utility and energy market, which is looking at IoT technologies, particularly in gateway technologies. I'm trying to convince them to look at water as the next vertical in this field. They don't treat me like I'm a sales and marketing professional or a technology guru, but hopefully I have some credibility. But the other area is in our labs. We have done some pretty interesting work, and particularly in Europe, in Dublin, in London, showing on the smart water grid side, showing how sensors and gateway technologies can, for example, help London spot ahead of time where to repair pipes. Predictive maintenance. London, like a lot of European and older American cities, loses huge amounts of its potable water to leakage. And so if they can get out in front of that. Same in Dublin. We haven't yet found a commitment to market those technologies, or typically we would find a partner because we're a component manufacturer. But the last area is in our venture capital. We have, I think, what would be the 1, 2, or 3 third largest venture capital pool if it were a standalone VC company. And we want to get a return on the investment, but primarily we're investing in companies that can create the demand for our next generation of chips. And so over time, we've invested in a number of sort of phase 2, or whatever the VC terminology is, after startup companies to develop the smart water grid concept.
Yeah, from the university perspective, I have a fun job. I run water research programs at ASU, and I have state research incentive money to hand out to professors to create new research context and new research endeavors. And then I get to connect them to people like these guys at the table. And so that's kind of the role I play, and it's an important role for a university to engage in, I think.
All right. We have any questions from the audience? Yes, ma'am.
Good morning, ladies and gentlemen. My name is Rosemary Segera. I'm a president of a company and an organization. My company is called Segera International, on manufacturing locally here and in Africa, where I come from, in Kenya. And my organization is called Hope for Tomorrow. We focus on humanitarian, which the most critical thing is water. I've been talking about water since I came to this country. World Bank, IMF, UN, everywhere. Nobody says the answer. The only thing you hear is, who wants the funding? What's the funding? How can we work? I'm not an expert like you. All I need is water. How can people get clean water? How can we have water for irrigation, agriculture, and this all? How do you coordinate people with the World Bank, the USID, United Nations, with all the information you have here? I think this is the most important information they need, more than just talking about water, water, water. Working with us who are civil society or organization or companies to extend the knowledge out there. So how will I work with you locally here and back there in Africa, where we have a lot of problem in refugee camps and everywhere? People need clean water, sanitation, and there's no water for sure. You hear mining, people who are mining, they need a lot of money. I just need water. How can we collaborate to ask money from the World Bank, from United Nations, to get this done and people to get clean water, manufacturing, and other things? Thank you.
Thank you, ma'am. So we've got some global perspective here. John, you want to take from maybe GE on how what we're talking about today would transfer to some of the needs globally?
Well, first of all, I think that was a really great point to make, that we're talking about water in a manufacturing context, and you're saying it's a much broader, much more important issue, and it's, essential to life, really. So I would just say that there are a lot of efforts globally to address water in what I would say is the developing regions of the world. And the U.S. Congress passed a bill. They called it originally it was called Water for the Poor Act, and I think they changed it into Water for the World Act, which provided funding for the U.S. State Department, and I think principally through USAID as kind of a executive, an arm to execute on the program, to work to try to address water issues around the world. And I know there's also an organization which, Steve, maybe or Tim, you guys know, but called U.S. Water Partnership, I think is the name of it, which has formed under the aegis of a foundation called Global Environment and Technology Foundation, where they try to bring together disparate efforts, whether it's a Gates Foundation or an NGO or some kind of a think tank or NGO or even government agency that's working on water issues, and try to get them to act in a coordinated fashion to make a greater impact than they could make perhaps independently. I know Coca-Cola is very involved in that. They have something called the RAIN Foundation. And I would just say from GE's standpoint, we have a corporate foundation that makes donations for water, and GE's water business unit has a program called Water for Humanity, where we give employees who want to go to principally sub-Saharan Africa, money, equipment, and time off to go implement clean water projects there.
Thank you. Any other questions from the audience? In the front, sir.
Hi, Mario Ordaneta from Enforcet. There's a phrase, you can't manage what you can't measure, what you don't measure. And so I wonder if in the manufacturing community there is an effort, or there are any efforts similar to, say, in energy, there's the ISO 50001 standard for measuring energy use, towards the goal of keeping tabs on how different industries measure water and hopefully gain awareness and
I think that's a great question. I think the future of measuring what you have and what you use is in IoT for what you use, and in satellites for measuring supply. And I think in terms of standards, the supply side is probably a ways off because the technology is still being developed, but it's computational, so it should be amenable to standards, I would imagine. And I could talk to you more about that offline if you want.
I'll take a crack at that too.
Yeah.
I mean, so kind of my experience with it. Your question is, I certainly agree. In general, kind of in the industrial setting, just the activity of measuring is kind of reported as being capable to create a 10 to 15% improvement in water efficiency. I'll say within the infrastructure assets I deal with, we have systems that do that very well, some that don't do it as well. One of the keys to that still is that water's very, very local or regional. And so generally what I find is in places where water stress is high, the influence on measurement and accounting and for sure even rate-based water use are important. And so I think there was an example offered up about Arizona and water efficiency. And as the price goes up, your willingness to measure for the sake of getting the financial remuneration correct improves. And then in places where, I mean, I can pick on, say, facilities maybe in Louisiana, intaking off the Mississippi River, where there's still a fair amount of one-pass cooling operations and things. There the focus on measuring isn't as critical. And so on any water problem, what I find is you really have to put it in a local context. One other aspect maybe to your question I'd really like to highlight is that not just measuring, but understanding for every unit process, kind of what maximum bar is important. And this is something that happens a lot in China, where they take a look at XYZ plant or this plant or the other, and they kind of have a pre-established unit ratio for what's good, what's bad. That is a concept that I think will hopefully proliferate more, so that you do have, for given sectors, a way to say, what does efficiency really look like?
Steve, you want to jump in?
Yeah, I'm going to take off my Intel hat here and put on the hat of my role as a board member at a group in Annapolis called the Chesapeake Conservancy, and focus on measurement and water quality. And this is true in a lot of large water bodies in the United States that have what are called TMDLs, or basically daily pollution budgets. And governments are trying to ratchet down those pollution budgets to improve the water quality over time of the water body. And it's what I'm about to say is applicable to any water body in the world. The reality is it's getting more and more expensive in developed countries to improve water quality because, by and large, at least I'll focus on the U.S., the water coming out of the cities, out of the POTWs, is pretty well controlled. And for DC water, for example, to wreak out another 1% of the stuff going into the Potomac, for example, is, probably $1 billion. I don't know the exact amount, but it's very expensive. Whereas for farmers which are contributing typically a lot more pollution than the cities, or for wastewater, stormwater systems, which is the other big source, it's a lot cheaper potentially. The problem is we haven't historically had good ways of low-cost ways of monitoring water flow, right? So, on the quality of water flow. And you have point versus non-point source pollution issues. You can measure exactly what comes out of a sewer plant. It's harder to measure what comes off of a farm field. So one of the things that we've been working on, US EPA has been doing a lot of work on, is developing low-cost water quality monitors. And what we've been working on at the Conservancy is the improvement of remote sensing and GIS technology, particularly so-called LIDAR imagery, which gives you the ability to see the exact contours of a piece of land. And it turns out in the Chesapeake region and a lot of other regions, the Mississippi is a good example, water does not flow off of a farm field in a flat flow pattern. In fact, in a lot of fields, there are rivulets, and it's actually kind of a point source. And if you could develop, as people are trying to develop, low-cost water quality monitors that could be placed in those rivulets, you could do trades between the farm fields and the sewage plants that you could monitor to make sure they had environmental integrity. And you could probably do it for 1 cent on the dollar of what the traditional approach is typically. And the last part of this is stormwater. In places like Washington, D.C., and D.C.'s actually got a pretty good stormwater offset program, there are tremendous opportunities to build greenways and other kinds of natural swale and part hard engineering, part green engineering. And so if you can use the remote sensing technology to spot the places where those solutions can have an impact and where you can monitor in a point source fashion what the results are, and again, do the trade with the sewage plants or even between them and a farm field, you could greatly reduce. And so technology is going to be a big I think, a big solution that can be applied to water quality problems anywhere in the world.
Thanks, Steve. And in what I think is probably a rarity here in the Congress, we're going to try and deliver you something the end time as promised and on time. And I want to conclude with a big thank you to Andy, to the House Manufacturing Caucus, to ASME, to all the folks at ASU, to Amanda, to Laurel, to John for helping put this thing on, and of course to our speakers, so to Steve, Tim, John, Valerie, and John, a big round of applause, and thank you guys.